Hey scholars, we are going to now start Chapter 8. It's called Ratios and Proportions. I think Chapter 8 is almost an easier chapter than what we've been doing. And Chapter 7 had all those area formulas and right triangles. But Chapter 8 works with similarity and ratios and proportions. And for some of you, it's going to feel very algebraic. But you're going to have to be able to look at the geometry picture and make it more algebra. I love this chapter because I always, I'm not always good, as you all know, about always saying, hey, here is the most awesome thing about math, and this is how it's used in the real world. Well, here's probably one of my favorite nerdy type things. My husband loves Lord of the Rings, and he has the extended versions, and we have all the bonus CDs, that type of thing. And one of the things they have is this little documentary that takes an hour about how they make to scale all the fortresses and sprawling cities and all that stuff in this studio, and they do it all to scale. So it's amazing, and how they use the ratios, and they also use ratios to make real life people look like a dwarf, or elves to look taller than they are. I mean, it's really kind of interesting. How do you think a hobbit was so much smaller when they're actually taller than the lady who's the elf? That type of thing. How do you do that? Well, it's all using ratios and scale, and put them in the right proportion, and continually put them in the right proportion as you go. So that's just kind of this is the type of stuff you'd use in that type of manner. But the first thing we got to remember, just some basics. What is a ratio? A ratio compares two numbers by division. You can write it as a whole bunch of different ways. You could write it in this way, A to B, all right? Or we write it in ratio notation. I call that ratio notation, using a colon. Or we can do it as a fraction, A to B. Now here's one stipulation. You can never have 0 for B, because if you did, you'd get A over 0. Oh wait, that's undefined. I can't ever divide by 0, so that doesn't work that way. For examples, though, we have the ratio of 1 to 2. We could rewrite it as 1 to 2 here, or 1/2. They all mean the same thing. And notice I keep saying this, 1 to 2, 1 to 2, and 1 to 2. Or we'd say 1 over 2. Well, we're doing a comparison here. Well, what are some common ratios that we worked with? How about slope? Slope is a common ratio. And we know by using the slope formula we can do that. It says write a ratio expressing the slope of line L. Well, that's easy to do. y2 minus y1 over x2 minus x1. Well, I'm going to go here, -2 minus 3 over 2 minus a -1. Well, that's a -5 over 3. That's our slope. And it's a ratio. What do we know? That tells us how far we go up. If we start at point A, we go down 5 and we run to the right 3. That's a comparison of the horizontal and vertical movement of a line. Okay, so that's how we do with it. Here's another ratio we had, and you guys didn't like these. The ratio of the angle measured in a triangle is 1 to 6 to 13. What is the measure of each angle? Well, and the one thing I taught you, anytime you have a multi-ratio like this, 1 to 6 to 13, you rewrite it as 1x is to 6x as to 13x. And now each one of those represents an angle. And so you just have to go x plus 6x plus 13x, and that's 20x, and they add up to 180. So 20x equals 180. Divide by 20. X is equal to 9. So then I just go 1 times 9 equals 9 degrees. 6 times 9 equals 54 degrees. And then we have 13 times 9, which gives us what? That's right, 117 degrees. Crazy, but that is the ratio of the three angles of that triangle. Now, we go a step further. If we just had ratios, it'd be no big deal, but we put them in equations. And so we have what's called a proportion. Now, a proportion is an equation stating two ratios are equal. We have A is to B as C is to D. Okay? Notice how I just read that. A is to B as C is to D. Now, in a proportion, we actually identify the different parts. And you're going to hear me use this terminology a lot this semester. I wouldn't say this semester, this chapter even more. A and D are called the extremes. And B and C are called the means. And notice they kind of go across. A and D are the extremes, and B and C are the means. Now, I like it when you write it strictly in ratio notation. Look here, A is to B as C is to D. Notice where A and D are located. They're located on the extremities, the outside. And B and C are in the means, the middle. And like when we talk about mean, that's like the average. So that's kind of how I memorize those. So the means are in the two middle positions. But I just want to remember those are the extremes. And we're always going to know, boom, those are going to be called the means. And we're going to use those a lot in different types of scenarios. So just a quick review of what ratios and proportions are, and now we're just going to apply them real fast.